Now you want to estimate your what I call the interactions, the main effects, both alpha and beta, the main effects, and then the interactions. This is a typical least squares problem. This is a typical least squares problem. You can think about how many equations will be there if you want to take a regression approach, meaning the rule based approach. You can, how many equations will be there? How many equations are going to be there? Suppose there are I levels for A and J levels for B, the total number of equations is I plus J plus, what about interactions? Now you have interactions also. I plus J plus Ij plus 1, that will be the total number of equations if you go by the rule, that is the total number of parameters to be estimated, right. Interaction at every level, every possible combinations, right. So I have I plus J plus Ij plus 1, which is the grand mean. So that is the total number of equations I would have, okay. So there are I plus J plus Ij plus 1 equations if you want to take it out, and then either you can go by the rule based approach, which would be easier if you remember the rules, that is the total number of equations, the right hand side and the left hand side, okay. But you can also do a least squares approach, you just start deriving the equations. So you are doing partial differentiation of the function, the loss function or the minimization of the squared errors with respect to mu, alpha, beta and alpha beta, okay. So then you can solve for it, okay. So either you do square regression approach or the rule approach for regression, okay. There are 3 rules which you have learned, right. The total number of equations, the right hand side and the left hand side. The left hand side is nothing but sum of all the parameters multiplied by how many times the parameter has appeared in the right hand side, okay. The right hand side is nothing but sum of the total number of times that parameters are appear, okay. So you can write out the regression equations and solve it, or you can use least squares to solve it, either way you will get the same answer, okay. So these are the parameter estimates after doing a least squares. So mu hat, as you should have expected, it is the grand mean, so it is y bar dot dot dot, okay. Alpha I just focuses on the ith row, so it should be y bar I dot dot minus y bar dot dot dot, the other one should be y bar dot j dot minus y. So look at this, these two are similar to what you would have seen in RCBD, there is nothing new here, these should have been same as what you would have done in RCBD, okay, where we have considered 2 independent factors, okay. What will be new is your interaction term. So your interaction term is yij dot minus yi dot dot minus y dot j dot plus y bar dot dot dot, this is something new, this interaction term, okay. This is the term which is new, the other 2 are same as your RCBD equations, okay. So now we have an estimate for all the parameters, okay. So now the next question is, I can substitute it, okay, I can substitute in the model, this is mu alpha I beta j alpha beta ij, and this is nothing but my eijk, right, because I now have an estimate of all of this. So I have the entire model replaced in terms of the estimates, the parameters now estimated and replaced, clear the steps. So now if you look at it, there will be, you should have guessed it, the sum square total should be sum square root of factor A, factor B, interaction plus a noise, okay. So these are the 4 parts, SSA plus SSB plus SSAB plus SSE, okay. So you have it as 4 different parts, A plus B plus AB plus error, these are the 4 different parts, okay, like your Latin square, Greco-Latin, where you have parts, we have also the interaction is something new. Okay. So now, as I said, these are the hypotheses one could make, okay, either on the two main effects or the interaction part. Clear? Then what do? We actually have the test statistics SSA. So before doing that, we would know what is expectation of SSA, etc. Okay, what is your expectation of SSA, the mean squared due to treatment A, treatment B and treatment AB. Okay. So this I have derived it for ANOVA, we can do the same here. So how do you start doing, what is sum squared error due to A? It is the estimate alpha I minus mu the whole square, that is what it is, alpha I minus mu the whole square, sum of alpha I or expectation. So you have expectation of alpha I minus mu the whole square, and what is the total number of data points? Expectation, right? What is the total number of data points? What is the total number? Expectation of sum squared. So what is sum squared A? Sum squared is alpha I minus mu the whole squared, okay, sum squared, and for when you take sum for how many data points? What is M here? M and Q, any idea? M is replicates and Q is it right? Q, what is Q? So M is the replicates and Q is the number of levels for factor A, that many times it should be there, right, number of Q, yeah, this is sum square, yeah, it should be for Q is for factor B, because for every factor of A you are looking at, yeah, MQ times summation of alpha I minus mu the whole squared. This is your sum squared A, okay. Now I am taking an expectation of sum squared A, okay. So this is some simple, for what is the sum? For all the levels up to P levels, okay. So you understand this equation, how did I get this? This is nothing but alpha I minus mu the whole square, okay, and I am summing it, okay, for all levels of A. So the total number of levels of A is P, so all levels of A, P is the levels of A, Q is levels of B, and M is number of replicates. So this part is alpha I minus mu the whole square for all levels, and for how many data? M replicates, each having Q columns, which is the levels of B. So if you go by that, what will be sum squared A, sum squared B, what will be sum squared B? So this is summation j equals to 1 to Q beta j minus mu the whole square M replicates for B. This is my sum squared B. Clear? Any questions, concerns, making sense? So then I could have, then I can take an expectations, I will leave it to you, I am adding and subtracting a few things and I will leave it to you, okay. At least the derivation is here, so you can verify if you derive. This is what sum squared. So finally the sum squared A should be a function of what? Should be a function of alpha squared, right, that is what we learnt in ANOVA also, tau squared, sum squared treatment will be a function of tau I square. So you will see that it is a function of alpha squared. And what is the degrees of freedom? The degrees of freedom is, what is the degrees of freedom of some SSA or MS, mean square treatment, mean MSSA, what is the degrees of freedom? Totally there are p levels, so you have p minus 1 degrees of freedom. Okay. So similarly going to sum squared B, okay, this is what I told, MP j equals to q. So this is what your, this is nothing but beta j, this is mu, okay, and this should be a function of beta j squared. The expected value should be a function of beta j squared plus a, of course, a variance term. This is exactly like your ANOVA if you start deriving. Now you have for 2 factors. The key part is of course, and what is the degrees of freedom? The degrees of freedom is going to be q minus 1 degrees of freedom. Now comes the interaction part, which is slightly newer to us, okay. So what is the expectation of, what is sum squared AB? How do you define sum squared AB? You wrote SSA SSB, what is SSAB? This is going to be summation, okay. Now it is a bilinear term, we call this as bilinear because it is a alpha times beta, xy is the multiplication term, its one time is bilinear. If I say xyz, we call it as trilinear, okay. So this is a bilinear term, okay. So multiplied across 2 variables, so you have multiplied with 2 variables, so you have I going from 1 to p, j going from 1 to q, and then I have a product which is alpha beta ij, right. Then this is squared, sum squared, this is squared, and what is it multiplied with? It is multiplied with only the number of replicates, okay. So this is what I should be having it as sum squared AB, both factors levels mean. So this will be, so this will be plus alpha bar I square minus beta bar I j squared plus mu, or if I write it, let me write it here clean. So this is sum squared AB is going to be okay. Then obviously I should have a subtraction term which should be mu I see, if I have to, that is, so this is what you will have actually. If I want to know, because the interactions are not there, it will be a whole square, because you see this is what your estimate is, this is what your sum squared interaction is. So you have alpha beta ij, okay, bar. So this is your actually your sum squared AB, but if you expand it will be simpler because there will be no interactions, that is why only alpha beta will be there, yi bar dot bar and y dot bar, so interactions will not be there. So this is my AB interaction effect, where you have, look at this, how did we get this, is because we estimated alpha beta to be here, okay, this is my alpha beta. So the moment I write alpha beta the whole squared, okay, that itself is what, is this term, where means are getting subtracted actually, okay, clear. So this is what my sum squared AB is, this is sum squared A, this is sum squared B, okay. So where one subtraction is there, your interaction term will have multiple subtractions, that whole thing I call it as alpha beta. Okay. So when I write it out as alpha beta the whole square, alpha beta itself is nothing but yi j dot bar minus y bar, all of this is included. This is how we estimated alpha beta. Clear? Clear everybody? Okay. So this is my sum squared. No. So this is my sum squared A. So this ideally is my sum squared B, and your sum squared AB is all this. This will be y bar ij dot minus y bar I dot dot minus y bar dot j dot plus y bar dot dot 3. Alpha beta itself is this thing, whole thing. Okay. So all of this will not be there because alpha beta itself is included, everything is included there. And what is the degrees of freedom for this? P minus 1 into Q minus 1, because individual degrees of freedom you are just multiplying P minus 1 into Q minus 1, and the error degrees of freedom is by subtraction. What is the total degrees of freedom? MPQ, yeah, M has to be included, that is what I have. MPQ minus 1 is the total degrees of freedom, because there are replications, remember. So this is P minus 1, Q minus 1, okay, P minus 1 into Q minus 1, and then I have total is MPQ minus 1, and this is by subtraction, PQ into M minus 1, that is a complicated one, you just get it by subtraction. Sum square error degrees of freedom is always by subtraction. Make sense everybody? And depending upon replications you use, things will vary. Again I said you can replicate exactly, you can only replicate the rows, you can only replicate the columns, or you cannot replicate both. Okay, you only do it at the, you have to replicate at least A or B or everything properly. Okay, if you do everything properly, then this is the formula. Remember we had different kinds of replications, I hope you remember, because you cannot always maintain everything constant, some things will vary. So either you keep one factor, both the factors constant, that is ideal, and that will be leading to a pure replication. But sometimes you cannot keep both constant, you can keep only one constant, then that will result in change of degrees of freedom of error. Okay, we learned how to replicate also, what are the different kinds of replications also. Here what have I considered? I have considered ideal replication. Okay, that is why P minus 1 into Q minus 1 degrees of freedom. If it is something is not replicated exactly, then that degrees of freedom will change. Clear? Okay. See, this is a systematic way, it may there is nothing, it may appear boring or whatever, but this is the systematic way to do experiments. No rocket science here, but no statistics, complete statistics, what is independent, what is dependent, understanding the assumptions. We will go through an example instead of doing all this business, we will go through an example. Okay. So let me take before this I had a data. So here is an experiment, okay, can we start doing ANOVA, 2-way ANOVA, start solving. By now you should be able to write the formula yourself without even computing much. So 3 levels of A, 2 levels of B, so total number of experiments, for one replication is 6, we have 3 replications, totally 18 data points. So this is given the cell totals does not matter, okay. So then what do I have to figure out? I have to compute sum squared A, that is mean squared A, basically be degrees of freedom we know, P minus 1, what is the degrees of freedom of A it is 3 minus 1, and then for B it is 2 minus 1, and then for AB it is 3 minus 1 into 2 minus 1, and error you total degrees of freedom is how much? 3 into 18 minus 1, 17. Okay. So you know the error degrees of freedom, you can calculate, right. All degrees of freedom is fixed. So what is sum squared A? This is what we have, yi dot bar minus y bar dot 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 the whole squared. That is what my sum squared array is, right. Not very difficult to compute, you can directly use this formula. So that is why I said you do not need to have a formula sheet or anything. If you understand, you should be immediately able to write for sum squared A, sum squared B, and as well as AB, right. So here is what we do. So the sum square total, okay, sum square total is what? Whole data minus the common mean. The common mean is sigma xi square by n, whatever, right. So then, so here I have used the, the same idea I have used. Basically this is what yij minus, what is this, this part, sorry, yeah, this one. You can directly use this formula, you do not need to simplify it even, because every value is known to you. You can compute yi dot for each I. How many i's are here? Only 3 i's, 3 levels of A and only 2 levels of B. So this is going to be sum squared A is going to be, m is going to be 3 into 3, 9 times, okay, summation I equals to 1 to 3, okay, y1 dot dot bar minus y bar dot dot the whole square plus y2 dot bar minus y bar dot dot the whole square plus y3 bar dot minus y bar dot dot the whole square. 3 rows, that is all. You will have 3 rows, right. Remember there are 3 rows in this data, 3 row sums you have to take, subtracted with the grand mean and take a squared. You do not need any simplification formula to remember, you can directly use the formula whatever we have derived it. Clear? This is what is sum squared A is, okay. The rest of the things, once you know one sum squared A, sum squared B, the interactions, you form a table like this. So this is my sum squared A, sum squared B, sum squared AB and sum square total. So error is always by subtraction, so no issues there, error is always by subtraction, okay. How did we error get 90? How did I get this 2337? Any idea? What is this 2337 is? SSA, SSB, T, see total itself is only 1226.5. How did I get this one as 2427? What is this 2427? Go check it out, okay. I cannot spoon feed everything, if you solve it then naturally the numbers, so go check it out, sigma, okay. So we just go by the derivation we did, we will have all the numbers come into picture, then it is a question of filling the table, it's a question of filling the table, okay. So far so good, right. Now you could do MSA by MSE, MSB by MSE. So now you can talk all this 3 hypothesis testing including interactions, clear. So one more example I have given, okay. So I hope you guys can solve it and then check for yourself, okay. So that completes our 2-way ANOVA, okay. So now What is the next step we have to look at if two-way ANOVA is done? So one-way ANOVA we did, now we know to do two-way ANOVA. What is the next natural step progression? N-way, right? We will try to do N-way ANOVA, and as well we will start doing screening experiments. We will start trying to focus on, the next class we will start trying to focus on what is known as screening experiments. Okay. The screening experiments become pretty important, because see these are at multiple levels. So this two-way ANOVA and this N-way ANOVA are all reserved. This is for doing detailed experiments. Okay. Suppose there are 6 factors to consider, 6 or 5, let us make it even simple, 5 factors to consider. How many interaction terms will be there? 5 factors, how many interaction terms are you looking at? It is a combination 5C 2. Do not think of alpha beta. So you have bilinear interactions, trilinear, quaternary, and all 5 together, right? Alpha beta gamma, alpha beta gamma delta, alpha beta gamma delta theta, all combinations are possible. So you will have certain in bilinear interactions, trilinear interactions, and build on, right? It is not going to be straightforward. Now should I consider all these interactions? Is all these interactions important or not important? Can we get to know easily? I need to do some quick experiments so that I can neglect some interactions and keep some interactions. What kind of experiments will you do? You see my question? See, 5 factors if you take, if you consider these kind of interactions in your model, the model is complicated and you may be unnecessarily having more terms, okay. And if I have this number of these levels, how many experiments should I do, right? How many replications I do? See, suppose if I take out M, what is the degrees of freedom for error? Just in this case I will take out M. What is the degrees of freedom? Make it M equals to 1. What is the degrees of freedom in this example? Degrees of error. So the total degrees of freedom is how much? M PQ minus 1. Make M to be 1. What do I have? 3 into 2 minus 1, 5 degrees of freedom for total. What is the degrees of freedom for A? 3 minus 1, 2. What is the degrees of freedom for B? 1. So what is the error degrees of freedom? Interaction degrees of freedom first of all, forgot. What is the interaction degrees of freedom? Again 3 minus 1 into 2 minus 1, 2. So what is the total degrees of freedom for error? This is what I want you to check. So what is the degrees of freedom for error if you have no replication with one interaction? 0. What does it tell you? Replication is mandatory. Replication is not an option here. When you do factorial two-way ANOVA experiments, keep in mind replication is, you can add by, so I will tell you it is not a difficulty, for anything it will be true. Why? P minus 1 plus Q minus 1 plus P minus 1 into Q minus 1. What is this equal to? P plus Q plus PQ minus P, what is the, what do I have? So this is minus 1 minus 2 plus 1, okay, PQ, and then minus P minus Q, right. So what is the total? Right hand side is also PQ minus 1. So what is the error degrees of freedom? Always 0. In a two-way ANOVA, the error degrees of freedom will always be 0 if you do not do a replication. So now this is just for when I include interactions. The moment I include interactions, the it will be 0 if you do not do replications. So how many replications should I do if I am doing 5 factors, 5 interactions, 5 factors into consideration. Crazy, right? Because the number of interactions get building up so fast. So what is the kind of experiments you will do? Some, let us call it as screening experiments. What kind of screening experiments can you think of? You understand my question? There are 5 factors, I cannot do experiments to systematically evaluate, it is impossible, because I told you, you have to anyway replicate, and one experiment how much, one row how much you have to fill, because it depends on the number of levels for each factor. It will become really large if you look at multiple levels. So what is the quick and dirty experiment that we can do? Each factor at 2 levels, each factor at 2 levels, yes or no, low or high, and then drew the graphs. Last class we did the graphs, right? Response graphs, that is called response graphs, we will look at it formally tomorrow. Response graphs and response surfaces. Do a quick and dirty experiment of yes or no questions, that is the screening experiments. You give 0 dosage, you give the highest, look at the outputs, see what interactions are, even graphically if you visualize it, even without math, you will be able to see what interactions are important and what are not important. So that those are called the screening experiments. Okay, people always, the chemists, everybody does this screening experiments for drug molecules to understand toxicity etc. levels. They do not go into detailed experimental plan at all. First screening experiments have to be done, whether it is even viable, suitable, no, toxic, is it less or no. Okay. So we will learn about these screening experiments, which is 2 factorial experiments, okay, before we do an NV ANOVA. Okay. Thank you.